Okay, I'm going to do a screencast here of problem number 767, and it's a ladder that's leaning up against a wall. I've got the problem right there, and I've drawn a ladder leaning up against a wall. It's 6 meters long. It's got a mass of 54 kilograms. It's tilted at 60 degrees above the ground, so that's that angle right there, above horizontal. Coefficient of friction between the floor and the ladder is 0.4. That's down here. You've got a 73 kilogram guy standing on the ladder, and what's the distance that he can pass without the ladder slipping? So the question is, here's a guy holding on to the ladder, and where can this person be along the ladder, which means, D is like this, and the whole thing is 6 meters long. So we have to draw a force diagram, a picture like this with a force diagram that shows the forces at their point of application, because this is an extended object. The torques have to add to zero, so we have to have this thing in static equilibrium. All right, so I'm going to draw my force diagram here. I'm going to have the mass of the person acting straight down, or the way the person acting straight down, the mass times gravitational force, and then at exactly 3 meters, right in the middle, you're going to have the mass of the ladder times little g. And then you also have a couple other forces down here. You've obviously got a normal force of the floor, and you've got the ladder wants to slide left, so you've got a friction force, a static friction force, which we're going to assume that's at its maximum, because that's going to be at its maximum when the person gets to his highest point there. Normal force of the floor, and then you've got a normal force here of the wall on the ladder. This would be floor on the ladder. So two normal forces, but they're not the same. One's the wall, one's the floor. Okay, so I probably should put on here that this is 3 meters to this point right here. Okay, so that's 3 meters from there to there. All right, so we're going to have a couple different equations. We're going to have the sum of the forces in the y direction, and we'll have the torque equation on the next screen. Okay, so let's do sum of the forces in the y direction first. Add up to 0. So I've got the ones going down, which is the mass of the person times g plus the mass of the ladder times g has to equal the normal force of the floor on the ladder. All right. Some of the torques have to add up to 0 because I'm in static equilibrium. Move that down here because I don't have enough room up there to write this equation. I'm going to make my axis of rotation, hopefully this makes sense to you, down here at the bottom, because I'm going to get rid of the floor force, which I don't know what that is, and I'm going to get rid of the normal force on the floor, because I don't know. Actually, I do know what that is, because I've got the mass of the ladder and I've got the mass of the yeah, I can figure that out. Hang on. Okay, so we've got 73 kilograms plus 54 kilograms equals the normal force of the floor on the ladder. So that's going to give us 730 plus 540 is 1270. So the force of friction maximum is going to be equal to that 1270 times 0.4, which is 508 newtons. All right, so that's the force of friction on the floor. So I'm going to change my axis of rotation, because now that I know that force, no, I'll keep my axis there, because some of the forces in the x direction tells me that the normal force of the wall on the ladder is equal to that force of static friction max, so that's equal to 508. So now I know this force right here, it's 508 newtons. So I'll have a torque equation here where I know everything but the D. All right, so let's set that one up on the next page where you got a little more room. Okay, sum of the torques equals 0 about that axis. So what I'm going to do is I'm going to keep the forces vertical. In other words, I've got this force here that's vertical. I need to find the perpendicular distance to that force. So the perpendicular distance to that force is just this leg of the triangle. So this is D right here, and then this is the 60-degree angle. So I want cosine of 60 times D is the length, and then M, the force, is the weight of the ladder times G. So the torque is the weight, sorry about that, is the weight of the ladder times that D times cosine of 60. Hopefully you can see that that is this distance right here. From this point to this point is D cosine 60 degrees, and that's the perpendicular distance to the weight of the ladder. I could also have said the force times the sine of 30 degrees, which would have given me, you know, this component of the force right here, but sine of 30 times the weight times D is the same as cosine of 60 times D, same thing. Okay, so that torque plus the mass of the person, oops, I'm sorry, that's not D. Sorry about that, guys. That is 3. That's the one I know. There we go. Now we're getting into the one where I don't know. Times D cos 60 there. There we go. That makes more sense. It's all going to be equal to that normal force of the wall on the ladder times 6 times cosine 60. 6 cosine 60 is going to give me the distance from here to here. You know, that distance right there. That's the perpendicular. Oh, I don't want to do cosine 60 as I just did that. I realized that because this is a horizontal force. So what I'll do is I will get rid of that, and I'm going to go to sine of 60. That'll give me the distance from the bottom here all the way up to that point up there at the top where that force is applied. Okay, so the only thing I don't know in that equation is D, so I just have to solve for D. Okay, so here I am with this. Let me solve for D, and then I will back up. I'll get all the non-D terms on one side, minus normal force of wall on ladder times 6 times sine of 60 equals D times MPG times cosine of 60. If I divide both sides by this, then I can solve for D. MPG Okay, hopefully I get an answer that makes some sense. So the mass of the ladder, I think, was 54 times 10 times 3 cosine 60 minus that normal force, which is 508 times 6 sine 60 all over the mass of the person, which is 73 times 10 times cosine 60. Okay, sorry, third mistake I've made on this so far. As I was trying to solve this, I just realized I got a negative number. So I screwed my signs up here. So this is a minus sign. Oh, sorry, that's not a minus sign. That's a minus sign. This is a plus sign. So this is going to be plus, this is going to be minus. Okay. I should have started with this, subtracted that term from this one, and then divided by mg cosine 30, mass of the person cosine 30, okay? Okay, I get, when I correct those two signs, I get 1830 in the numerator, 365 in the denominator. When I divide that out, I get 5.01 meters as the farthest that guy can go up the ladder before it starts to slip. So if he goes higher than that, then the torque caused by his weight, which would be the mass of this guy right here, that's going to be bigger than the friction can offset. So there's no way that the ladder won't start to slip at that point. Okay, so hopefully that helps you understand 767.